Okay, so now that we're past the halfway point of this chapter, we are moving on to 2.4. And 2.4 covers something called deductive reasoning. So we're going to talk about two different laws today. And one of those laws is the law of detachment and the law of syllogism. So in order to understand these laws, you have to understand hypothesis and conclusion, which is basically the last week or so we've been hammering home the idea of hypothesis and conclusion. So the first law we're going to talk about is the law of detachment. And the law of detachment states that if the hypothesis of a true conditional statement is true, then the conclusion is true. So if the conditional statement is true and the hypothesis is true, we can assume the conclusion is true. So in example 1, we're going to use the law of detachment to see what we can conclude from the given information. So the statement we're given is, if there is lightning, then it is not safe to be out in the open. Marla sees lightning from the soccer field. So the hypothesis of our original conditional is there is lightning, right? There is lightning. Then it is not safe to be out in the open is the full statement. So circling the conclusion, it is not safe to be out in the open. So to complete number 2, we read this out and we underline the correct word or phrase, or you can circle it, doesn't matter. But it says, Marla sees lightning from the soccer field. Does that fit the hypothesis or not fit the hypothesis? I would say that that fits the hypothesis. So I'm going to circle that. Right? I'm going to circle that because it fits the hypothesis. If there is lightning, the hypothesis is there is lightning. Marla sees lightning, there is lightning. So the conclusion we can draw from that is that it is not safe to be on the soccer field. Now, that's a situation where it's kind of obvious that it's not safe if there is lightning, but it's more about the logic of it, understanding when a conditional statement is true and picking apart the hypothesis. So if the hypothesis is true and we are given a true conditional statement, we can assume the conclusion is true. In this case, that it's not safe to be out on the field. The second part of this, the second law, is called the law of syllogism. And the law of syllogism states, or says that you can state a conclusion from two true conditional statements when the conclusion of one statement is the hypothesis of the other statement. So that's a little wordy, so we're going to go through some examples to illustrate this. So example 2 has us use the law of syllogism, and it asks, what can we conclude from the given information, and what is our reasoning? So if a number ends in 0, then it is divisible by 10, is our first conditional. Our second conditional is, if a number is divisible by 10, then it is divisible by 5. So what we're looking for law of syllogism is the conclusion of one statement being identical to the hypothesis of the second statement. So with our two statements, identifying P, Q, and R, P, the original if statement in our first, the original if statement in our first statement, the original hypothesis, a number ends in 0. That means it's divisible by 10, which matches the hypothesis of the second statement. So Q is the conclusion of the first statement. R is the hypothesis of the second statement. So we are deciding whether each part of the given information is true or false. So if P, then Q, the first statement. If a number ends in 0, then it is divisible by 10. That is true. Okay. Q, then R would be, if a number is divisible by 10, then it is divisible by 5. That's also true. Numbers that are divisible by 10 are divisible by 5. So the final one you're going to have to pay close attention to. If P, then R is, if a number ends in 0, then it's divisible by 5. That is also true. Because if a number is divisible by 10, then it's divisible by 5. And if a number is divisible by 0 or ends in 0, then it's divisible by 10. So those are both all true statements. So the law that we're going to write is if P, then R. Original hypothesis, last conclusion, right? Second conclusion. So the way I would write this out, I know this piece of ink is following us, but it says write your conclusion. So meaning write the if-then statement that combines the two statements. So my statement is going to be if a number ends in 0, then it is divisible by 5. So I take the hypothesis of the original statement and the conclusion of the second statement, and I write them as a single statement. But those have to be true in order for me to combine those two statements. Okay, so in example 3, we are going to be using both the laws of syllogism and detachment. And I'm asking you, what can you conclude from this given information, and what is your reasoning? So the statement says, if a river is more than 4,000 miles long, then it is longer than the Amazon. If a river is longer than the Amazon, then it is the longest river in the world. The Nile is 4,132 miles long. So I look at P, Q, and R. P is the original hypothesis of the very first statement. So that hypothesis is a river is more than 4,000 miles long. Q is the conclusion to the first statement. It is longer than the Amazon. That is also the hypothesis of the second statement. A river is longer than the Amazon. So this middle statement, than, T-H-A-N, longer than the Amazon. So those two statements are the same. Conclusion of one, hypothesis of the next. The final conclusion of the second statement, it is the longest river in the world. It is the longest river in the world. So using the law of syllogism, we take the two statements. We understand that the conclusion of the first is the same as the hypothesis of the second, which means we can combine hypothesis of the first, conclusion of the second. So the conditional we can write is if a river is more than 4,000 miles long, the original hypothesis, the first statement's hypothesis, we can use the last statement's conclusion. So we would say then it is the longest river in the world. Okay, so that's the law of syllogism. You have two statements. The conclusion of one statement matches the hypothesis of the other statement. So you can basically combine those as one conditional statement. But it's noticing conclusion of one, hypothesis of the other are the same statement. So the final thing, we're going to use that last statement in this whole paragraph. The Nile is 4,132 miles long. The law of attachment would allow us to say from our earlier statements, this makes the hypothesis of our final statement true, because the Nile is more than 4,000 miles long. So what that means for our conclusion is the Nile is the longest river in the world. So some of these things seem a little bit like common sense, but it's about evaluating hypothesis and conclusion. That's why we spent so much time talking about the hypothesis and conclusion of statements the last few lessons. So you're going to have some practice on this, but it's going to be a little less writing than normal. So I wanted to give you guys a little bit of a break from that after what we've covered before. You're still going to have to write on the next quiz. You're still going to have to write for other practices. But for this specific one, I'm going to give you a bit of a break from the writing.